The next topic is dummy variables. Dummy variables is the concept that we use to consider a categorical variable as an independent variable. Categorical variable is one where we have values that identify the category to which an observation belongs. So we start off with a categorical variable that has only two levels, two possible values, like management major or non-management major, or male or female, or smoker or non-smoker. So when you have only two possible categories, then that categorical variable can be represented by just one dummy variable. So you code one category as 0 and the other category as 1. Okay, so it doesn't matter which one is 1 and which one is 0, so you can arbitrarily make that choice. So whatever but at the time of interpreting the slope coefficients, you have to keep that in mind. Which category was coded as 0, that's your base value, and which category is coded as value 1. Okay, so that makes a difference in terms of how you interpret the slope coefficient. Okay. Now if you have more than two categories, then you have to define multiple dummy variables. You can't simply use 1, 2, 3. Okay, dummy variables or variables that can take only two possible values, 0 or 1. You can't have more than two values for a dummy variable. So if you have a categorical variable that can take multiple values, for example major, so you have say 4 majors: management, marketing, finance and accounting. So 4 majors. Okay. Now you cannot have 1, 2, 3, 4 as values from the dummy variable, because dummy variable, remember, can only take 0 or 1. So what we need to do is to define dummy variables, several dummy variables. Now it turns out that you need one less than the number of levels. So if you have 4 levels, then you need 3 dummy variables. You define a dummy variable for management, 0, 1 if it is management, 0 otherwise, and then 1 if it is marketing, 0 otherwise, 1 if it is finance, 0 otherwise. Now you don't need a fourth one, because if these 3 dummy variables are 0, then automatically that would mean that the category that the observation belongs to is the fourth one. So it is important that you define exactly the required number of dummy variables, no more, no less. If you define 4 dummy variables where you have 4 categorical values, that would be wrong, because it leads to what is called singularity. So if you have 4 possible categories and if you define only 2 dummy variables, that would be wrong also. So you have to be exactly correct. K is the number of possibilities, then k minus 1 is the number of dummy variables you need. So here is an example. Suppose we have 2 independent variables, the price of the product, and then x sub 2 is whether the week contains, so this is weekly sales, so whether a holiday occurred during the week or not. So that would be 0 if a holiday did not occur, 1 if holiday did occur. Then here is what the regression equation will look like. So your b sub 0, b sub 1, x sub 1, which is the price, and then the second x sub 2 is either 0 or 1. So your regression equation turns out to be b sub 0 plus b sub 1 x sub 1 plus b sub 2. In other words, p sub 0 plus p sub 2, your y-intercept is here, and then b sub 1 is the slope for the line. So in the case x sub 2 is 0, then you get simply b sub 0 and same slope going this way. So one line for x sub 2 equal to 1 representing holiday, and one line for x sub 2 equal to 0 representing no holiday. So that's what dummy variable turns out to be when a given dummy variable has only 2 possible values, or a given dummy variable is for a categorical variable having only 2 possible values. So here is an example of that weekly sales of pies. So you have the price and the coefficient for price and the coefficient for holiday. So here, since we coded holidays as 0 or 1, no holiday or holiday, so if the week has a holiday, then you are going to sell 15 more pies compared to a week without a holiday. So the compared to is when the dummy variable is coded as 0. Now let's look at an example in Excel file.